Welcome to the Lionheart Academy. This is Richard Tai. We're continuing our trigonometry lesson number 12, and we have talked about most of the conceptual ideas of how to deal with functions of acute angles. So this lesson, starting from today, we're going to talk about the application side. How are we going to use what we have learned so far? Now, one of the major things we can use our what we have learned so far is to solve a right triangle. Now, what do I mean by solving a right triangle? So let me go ahead and draw a right triangle here for you guys, just in case. Let's go ahead and take a look at the right triangle here. So let's say we have a right triangle here, and of course, if I know this is a right triangle, if they tell us it's a right triangle, there must be a right angle. So solving a right triangle is to find all the sides and to find all the sides and all the angles of the right triangle, and there are several cases. There are two specific cases that we're going to encounter. The first case is that they've given us one acute angle and one side. The second case was actually we don't have to write this, given two sides. Okay, so in both cases we assume that we know the triangle is the right triangle, and we know the right angle right there. So angle C, we always remember, we call angle C, it was our right triangle, and we have angle A and B. So in this case, we have side A, side B, and side C being the hypotenuse, angle C being the right angle. So in case 1, they would give us the right, we know that there's the right angle here, and they would give us one acute side. So one acute angle is either angle A or angle B, and we know either side B, or side C. So that's the case 1. And case 2 is that we only know angle C here, but we do know two of the sides, side A, side B, or side A, side C, or side C, side B. When we are given those informations under those two cases, then we will have enough information to solve for the right triangle. Okay, so let's start with taking a look at case 1. Alright, so let's do an example here. Example for case 1. Alright, so let's say given side angle A, is 42 degrees, and side B is equal to 12 inches. We want to solve the right triangle. Alright, so first thing we want to do is we actually want to draw a fairly accurate figure. We don't have to draw an exact figure, but you want to draw a fairly accurate figure, and you want to label it correctly, because that way it will help you understand the situation correctly. So you don't want to draw something that's not accurate. So for example, if I have a right triangle here, now I say angle A is 42 degrees. Now I would take a look at two of my acute angles. I think, well, this angle is probably a little larger than that, so I'm going to put my angle A here, so I want to be as fairly accurate as possible. And then I want to label everything. Okay, so this would be angle B, so that means side B would be here. Alright, so you want to go ahead and label everything. Okay, after you label everything clearly, you can ask yourself, okay, so what's the first things we know? Well, I know this angle C is 90 degrees, angle A is 42 degrees. So the first thing I can solve is okay, I forgot to label side A. The first thing I can solve, the probably easiest one, is to solve for angle B, right? Because angle B is going to be complementary to angle A. So that means angle B will be 90 degrees minus angle A. So that will become 90 degrees minus 42 degrees. So that will give us 48 degrees. So angle B will be 48 degrees. So I'm now going to put a number next to angle B. But I put it in red, so we know that that's something we solved. Alright, so the blue ones are the given, and the red ones are solved. Right, now we got all three angles. That's great. We still have only one side. We need two more sides. Okay, so now is where we need to come in and use our sine, cosine, and tangent functions, or we could use all 6 of the trig functions. So let's start with side A. Okay, side A is related to angle A. Of course, it's the opposite leg, and side B is the known leg. Is the known side is related to us as the adjacent leg to angle A, right? So what we can do is we can relate angle A and side B using which function? Think about it. Which function relates the opposite leg and the adjacent leg? Well, if you say your answer is tangent, then you got it right. So tangent of angle, let me go ahead and write it down first. Tangent of angle A is equal to side A over side B, right? Tangent angle A is side A over side B in this picture. So that means tangent of 42 degrees is equal to A divided by 12 inches. So what it means is I can solve for side A by multiplying both sides by 12. So multiply both sides by 12, so A is equal to 12 times tangent of 42 degrees. And then now it's time for us to take out our calculator and then type in this in your calculator to find out the numerical answer for side A. When you use calculator, you got to make sure your calculator is in degree mode, because right now we're using degrees, so you have to make sure that you are in degree mode. Otherwise, your numbers will not make sense. So here we got 10.80, so it's about 10.80 inches. I rounded off to the hundredth place, so it's 10.80. Okay. All right. So let's go ahead and go back to our graph. We can label this as 10.80 inches. Okay. Alright, we have one last side. We have to use some angle to help us solve side C, or there are two ways to do it. We can use a Pythagorean theorem. A squared plus b squared equal to c squared. We can solve C like that. Or we can use a tangent function, or a sine function, or a cosine function, or whichever function we can to solve for C, because C is the hypotenuse. So that's probably easier. It's probably easier to use tangent in this case. Use one of the trig functions in this case. For example, I got B is 12 inches, right? So the cosine of angle A will be the adjacent leg, which is B divided by the hypotenuse C. So I can solve for C very easily by multiplying both sides by C. So C times cosine A will be equal to B, but I already know B, so I want to solve for C, so I divide both sides by cosine A. So C will be equal to B over cosine A. Okay, so there's just a little algebra manipulation there. Alright, so then our side C will be 12 inches divided by cosine of angle A, which is 42 degrees. So again, let's type in our calculator to see what we get. So what I got here is 16.15, well 16.147, so I rounded off to the hundredth place, so 16.15 inches. Alright, so that is an example of solving for a right triangle. We got all three sides and all three angles. This is called case 1 because we're given an acute angle and then acute and then one of the side. So this is 16.15. Okay, hold on, the color is not right. It should be 16.15 inches. Okay. So that's called solving a right triangle. Alright, now let's take a look at case 2 and see how we solve that. So example 2, case 2. So given two sides, alright, we're given two sides. Side A is 16 inches and 16 centimeters, and side C is 27 centimeters. So let's make a diagram and label side C. Now I know angle C will always be a right angle, so side C is going to be 27 centimeters. It's going to be So side C is 27 centimeters, okay, just like we were saying, and side A. Now, I'm not too sure where side A would be, right, in this case, because I don't know the measurement of angle A versus angle B. So, I guess in this case, it's alright. We just put angle A here, angle B here. So let's say call side A 16 centimeters right here, and side B here, okay. Alright, so we got two sides already, but we don't have either angles. So how do we go ahead and solve this? Well, there's two ways we can do this. We can actually solve for side B first using a Pythagorean theorem. We can do that, or we can go ahead and solve for side A and side B. So I'm going to show you how to solve for what I meant angle A and angle B. Now let's take a look at angle A. Side A is the opposite leg and side C is the hypotenuse. So I have a function called sine. I know sine A will be equal to A over C, and then I know A and C. So let's go ahead and substitute sine A equal to A, which is 16 divided by 27. The centimeter will cancel out. Okay, so this is a ratio. I can't simplify it anymore, but I know sine A is equal to this ratio. What do I do with that? Well, on your calculator, there is a function called the inverse sine function. We haven't really talked about inverse sine function yet, but we can actually use the inverse sine function. It's written as sine of -1, or actually called arc sine. It might look like a sine, okay, like this on your calculator. It might depends. It looks like sine to the raised to the negative first power, but actually it's pronounced inverse sine function. So what you need to do is you need to do this inverse sine of 16 over 27, and that will return you an angle. That will return you the angle measurement of an angle, which is angle A. Alright, so let's try that on your calculator. Alright, so after I type in calculator, I got 36.3 degrees. I'm going to round it to the 10th. So angle A is should be 36.3 degrees. Okay. Now after I get that, I can go ahead and determine measurement angle B, because I know the two acute angles are complementary. So angle A is 36, then angle B is 90 minus that. They're complementary again. Okay. So it's 90 minus 36.3. That would be 63.7 degrees, right? No, 53.7 degrees. Okay. So angle B is going to be 53.7 degrees. Alright. Alright, then the last side B is going to be very easily solved. We can use tangent B, right? Tangent angle B is equal to opposite leg. Actually, no. I'm sorry. Yeah, I can use tangent. Tangent is, I can use tangent or sine, either way. Okay, tangent of angle B is going to be opposite leg, which is side B, over adjacent leg, which is side A. So tangent of B will be equal to, or I should say, if I want to solve for B, multiply both sides by A, it will be A times tangent of angle B. So let's substitute the number in. So 16 times tangent of 53.7 degrees. So let's type in your calculator, and we got 21.78 centimeters. Okay, after rounding to the 100th. Okay, so that's it. We down 21 point. We have solved the right triangle by using all the information given to us. All right, so this is this is a little bit more difficult because you have to use something called the arc sine, or inverse cosine, or inverse tangent. But we can always go ahead and do that using a calculator. You have a calculator, you will be able to use the inverse function to get the measurement of one of the angles. Once you get the measurement of one angle, it's going to be very easy to find the measurement of the angle, and then you can use the sine function to find the other side. This is not the only way to do it. We can use Pythagorean theorem to find side B, but I believe this is actually a little bit easier in terms of calculation, so it will also will allow us to make less mistakes. Alright, so I think this is it for today. We're just going to continue our lessons next time. Please leave any questions and comments in the comment section below. We thank you, and I hope you join us next time for the next lesson.